So let's take a look at this fun little program. So what this is doing is it has, I'm going to need to change that to constant. Okay, so this is an array of C strings, and we have to use the word constant because you cannot change strings, so the compiler makes you declare that as a constant. Then I'm going to create a pointer variable which will be an array of pointers. So this is what that means, right? It's a pointer to a pointer. This is going to contain, this is an array of pointers. So it'll be 4 characters long, or 4 C strings long. So to visualize this, let's go over here. And I'm going to walk through this code. Whoops, let's change that to constant. And this is pretty fun. So I'm going to walk through here, and you can see that colors is an array of pointers. Okay, and then those strings are created in memory, and then each of these cells points to one of those C strings. So that's pretty straightforward. Then names is going to be a pointer, and it is going to point to an array of 4 pointers. Okay, so it's a pointer to an array of pointers. And then I'm going to loop through, and I'm going to allocate enough memory to store each of the colors. So the first time I'm going to allocate 4 characters, 3 for the red, the RED, and then 1 for the null terminator. So the length of the string plus 1. So when I hit the next, you can see that it allocated, right, an array of 4 characters. And then I'll do a string copy, so it copies in the red. And then I'll go to the next, and it will count up the characters in this C string, and it will dynamically allocate that enough memory for that C string, and then it will do a string copy. And then I'll go to the next color, which is blue, and then the next color, which is yellow. So check out all of the new, how much memory did we borrow from memory? Or yeah, from the heap. So this is on the stack, right? And this is the stuff that we are borrowing from the heap. We didn't actually borrow the constants. Those are just stored. It's in read-only storage, not the heap. So it's not actually in the heap. But look at the things that we stored on the heap. We have this array, right? We borrowed that memory, an array of pointers, and then we borrowed memory for an array of car. Okay, so that's quite a bit of memory. So if I go back here and I run the program, it all works fine. But then when I run valgrind, you can see we lost quite a bit of memory. Okay, so what visually I'm going to do is I'm going to loop through this array, and I'm going to deallocate each of these car arrays. And then as soon as I'm done, I have to deallocate this array. Okay, so if I go back here, I'm going to loop through. I'm going to delete each of those car arrays. So delete names sub I. Okay, so since I'm deleting an array, I have to put that there. right? And then I don't need to set that to null pointer because I'm going to be deleting names at the end. So I'm going to go through and do that. And as soon as I'm done, all that memory will be freed up. All right, so if I run this again, and we'll run it through valgrind. Okay, so the indirectly lost, now there are 0. There's still 32 bytes, but now we haven't indirectly lost any. So those bytes were all of this down here, but now this is lost up here. Okay, so to fix that, I will delete names, and then I'll set names to null pointer. So let me run that, and then valgrind it again, and there you go.